The following process that I'm about to show you will work for any device that can be presented to your system. If you plug in a USB drive to your Linux system, create a new virtual disk for your Linux VM, or present a virtual volume to your Linux cloud instance, you can use this process. It's important to point out that what we're about to do will remove all the data that exists on that device. I have a virtual machine here, and what I'm going to do is present a physical, or I guess a virtual disk to it in this instance. So again, I'm going to make sure it's powered off. I'm going to go to the settings of that machine. I'm going to add some storage here. Just create a new hard disk device. We'll create a new disk, and we'll leave it at 8 GB. That's fine. Again, this would be the equivalent of physically putting another disk inside a server. So now I'm going to power that server on. Okay, now the system is booted, and I'm going to go ahead and log into it here. We need the Crypt setup utility in order to set up LUKS and encryption on our system, and it doesn't look like it's currently installed on this one. So typically I would just search for the software here. It's a CentOS 7 or a RHEL 7 equivalent machine, and I'm just going to use yum search, Crypt setup. And then I can see that the package name here is Crypt setup. I do believe on earlier versions such as Red Hat 6 and CentOS 6, it's Crypt setup-LUKS. So I'm going to go ahead and install Crypt setup now. We also attach the disk before we boot it up. Let's run fdisk-l to list the devices in our system and see if we can find out what device file is associated with our disk. Here, dev SDA, which is already being used, is 85 gig. That's not it. But if you look below that, dev SDB is about an 8 GB drive, which is the size of the disk that we presented to this system. So the device is dev SDB for this new disk that we installed. If you want to ensure that no unencrypted data is left on the device that we're about to encrypt, let's fill it with random data. Doing so will also conceal or obscure the parts of the device that contain encrypted data as opposed to just random data. To do this, we'll use a utility like shred. I'll do shred-v, which is for verbose, -n, which is the number of iterations, and I'll do just one. We'll just pass over this device once, and we'll supply the file here, dev SDB. What this command is doing is writing random data to that disk. Next, we're going to initialize the device. To do that, I'll run sudo crypt setup LUKS format and then pass it that device. This will go ahead and ask us for our passphrase here. Now that it's initialized, we can go ahead and open the device. We'll run crypt setup LUKS open and pass the device to it, which is /dev/SDB in this case, and a name that will be used to create the virtual block device in /dev mapper. So we'll just use opt as an example. Supply the passphrase. That opens the device, and now we should have a virtual block device in dev mapper. Let's just look at the last few entries there. You can see that the virtual block device was created in /dev/mapper/opt. Now we can use that virtual block device like any other block device. I'm going to go ahead and just put a file system directly on that device. So we'll run mkfs, we'll make it an ext4 file system. We'll run that on that device there. Okay, that's created. So now let's go ahead and mount our file system on /opt. I'll create an entry in the fs tab for it. Dev mapper opt. We're going to mount it on /opt. It's an ext4 file system. We don't need any specialized mounting options, and that will be our entry there. So we can go ahead and mount that device. And when we look there, we can see that opt is mounted on /dev/mapper/opt. Now, when we create files and place them in opt, they will be encrypted. From this point on, we use the file system like we normally would and allow LUKS and decrypt to handle the encryption. Here, I'll just create a simple little file. Oops, I need root permission here. We'll do it like this. In order for the device to be mounted at boot time, we'll need to make an entry in /etc/crypt tab. This will cause you to be prompted for the passphrase during the boot process so the device can be opened. The first piece of information we need to supply is the name that we used, and here we used opt, so we'll just place this here, and that will be the virtual block device that gets created in /dev/mapper. Next, we need to supply the underlying block device. Here it's /dev/sdb. The next field in this file is for the passphrase, but we can specify none here, and that will force us to be prompted for the password on boot. The last column here is for options, and we're just going to use the LUKS standard format. So we'll type in LUKS there. Go ahead and write and save that file. Also want to point out that the Crypt tab supports the UUID equals, UUID syntax, just like the FS tab file does here. And you can get that information by running blkid, and then you can see the UUIDs of these block devices. And then the one we're looking for is the crypto LUKS device, which is in this case /dev/sdb. So if you wanted to use this format instead of supplying /dev/sdb in the Crypt tab file, you would instead supply UUID equals 21125, etc. there. This is probably a better option for removable devices that you can't guarantee will have the same physical device file associated with it at each boot. So now that we have the Crypt tab set up, let me just go ahead and quickly show you that it will ask for the password when we perform a reboot. There it is. It's asking for our password. We'll go ahead and enter it. Quickly log in here. And you can see that opt is mounted on that virtual block device file of /dev/mapper/opt. Let's say you didn't want to automatically mount this volume on boot, but instead you want to use this device for a while and then stop using it. So let's go ahead and remove its entry from etc crypt tab. I'll just comment it out there. And also remove it from FS tab. Again, I'll just place a comment there. And let's go ahead and reboot.